Okay, let's talk about how to solve some exponential and logarithmic functions in general. So for example, if you have this, b to the u is equal to b to the v. So it's a kind of a simple one. So if you have two sides to an equation and the bases are the same, if the bases are the same, the exponents must be the same, right? This is the only logical way to explain this. Same thing here. If you have two logs, they have the same base, then whatever is inside must equal, right? This is logical. So let's kind of think about this. What does your math sense tell you need to do first to solve this? Divide by 20. All right. What do we do next to solve this? Yes, so if somehow both of the sides can have the same base, we can solve this very easily. So how do we change 1/4 so that it has a base of 1/2? Okay, 1/2 squared. So both sides have a base of 1/2. That means their exponents must equal, right? Okay, so x over 3 must equal 2. So x must equal 6. Easy. Okay, so just quick review. Make sure you follow your logical math order. All right, so let's have you practice solve this next one. Okay, practice. So this one, the answer is -4. Okay, let's before we go on to the next stuff, let's make sure we remember how our graphs should look like. E to the x. This is e to the x, or generally any exponential function. What is the domain? All real numbers. So this year we're really getting, trained on all your parent functions. Like we're getting back and forth, every single parent function, analyze, because next year you need to be able to do all this without a calculator. So you're going to be solving e to the x log and all that stuff with no calculator as reference. So you need to have an idea of how that shape should look like, what should the domain be, and all that stuff without any kind of aid. Okay, so make sure you're memorizing them as you go this year. Any log base b. What is the domain? 0 to infinity. Do we include 0? No 0. In fact, log cannot have any number that is smaller than 0. So 0 is going to be undefined, negative is going to be undefined. You have to remember that fact, especially for tomorrow. How about this one? This one's a little strange. Log base b of x squared. All real? Everything but 0. Yes, everything but 0. So x cannot equal to 0. Or we say negative infinity to 0 and then 0 to infinity. So we said that logs cannot accept numbers that's less than 0 or smaller. However, negative numbers, when it goes into this function, gets squared, so it becomes positive. So then it didn't matter. All right, let's solve a question. All right, this one's pretty hard. E to the x minus e to the negative x over 2 equals 5. We're going to solve it by graphing first. So you need your calculator. But what should we actually do? Like, what do we actually put in the calculator so that a calculator can solve for us? Think. What do we have to plug in? We have to subtract the 5. Let's make it a little easier. We don't like the fraction, right? Fraction is a little bit hard to work with. How do you get it? Times 2, yes. Times 2, so then e to the x minus e to the minus x is equal to 10. Okay, now what do we do? What do we have to do to the equation so that we can solve or plug into the calculator to solve? Subtract 10, good. E to the x minus e to the minus x minus 10 equal to 0. All right, now, what do we put in a calculator? That equation, what are we looking for? The 0. So what does that look like on the calculator? not the actual graph. So on the calculator, we plug it in. What are we looking for? If you don't know what you're looking for, why do you put it into the calculator?
Are you asking us
No. Put it in the calculator. Now, what tells you what is the answer? The 0. So that means what? Yes. So when is the graph going to cross the x-axis? The question is, which point crosses the x-axis? Does that make sense? That's why we always make it equal to 0, because we're trying to see where does this cross the x-axis. Okay, so you're going to do that. You're going to try to figure out what number makes it equal to 0. Your graph looks like this. You need to use the calculator to calculate the zeros. Second, trace. That's the calc button. You need to find the one that says 0. You have to use the calculator to calculate for you. It's going to ask you for left bound, right bound. You got to do that, and then it's going to give you a number. Okay, so this is the last time I'm going to say this. Next time you ask your partner, because we got to practice this as we go. It's going to give you a number. When x is this, y is 0. So what number is that? 2.312. All right, so that is the answer. Now we're going to solve this algebraically. We better get the same answer. Okay, we're here. E to the x minus e to the negative x minus 10 equals to 0. How do we solve this? It's a little hard. Okay, Yes, but natural log is not a distributive property. We can't distribute. Right? We can only distribute things that's linear. We don't have to. Okay, so what we're going to do is first change this. So it's 1 over e to the x. So remember, any kind of negative exponent means that you move it to the denominator. Tell me what you want to do next. A guess is better than no guess. How about get rid of the denominator? What can we do? Yes, times e to the x. All right, that's going to distribute. What do we get? Please remember all your exponent rules. This is very sad. E to the x times e to the x is what? No. Okay, talk to your partner. E to the x times e to the x. We gotta know this, or else I put you back in algebra 2. E to the x times e to the x. Chapter P, if you forgot. First chapter of the year. E to the x times e to the x. Nobody knows. E to the 2x. When you have the same base, you add the exponents. Ugh. Okay, e to the x times 1 over e to the x. Minus 1. Okay, minus 10 e to the x equals 0. All right, that's not quite helpful, or maybe it is. We're going to rearrange this. So it's e to the 2x minus 10 e to the x minus 1 equals to 0. Now we're going to remember what we learned in Algebra 2. When we cannot solve something like this, but it's very, very similar to things we have seen before, we do this. So you can see it's e to the 2x and then you have an e to the x, and then a constant. So in a way, I can think of this like this, e to the x squared. So, all right, review. E to the x times e to the x is e to the 2x. E to the x squared is also e to the 2x. Same base, add the exponents. Power to a power, multiply. Okay, this becomes e to the x squared minus 10 e to the x minus 1 equals to 0. We're going to remember Algebra 2. Algebra 2, we had this section about substitution. When things are not solvable or we have not, we don't know how to do it, we can use substitution. If we let a equal to e to the x, we can say this is a squared minus 10a minus 1. E to the x is just a in this case. Okay, how do we solve this? Okay, factor if it's possible, but is it factorable? No. So then quadratic formula. Negative b plus or minus square root of b squared minus 4ac all over 2a. Okay, solve it. Use your calculator. You're going to get two answers. Okay, what two numbers did you guys get? Huh? Oh, 11.1. No. 10 point what? Okay, let's not round so much. Because once you start rounding, you're going to get the answer farther and farther from where it should be. So 10.099. You want to keep at least 3 digits. The more, the better. Okay, what's the other number? Negative? 9. Yes. None of those answers match what I got before, right? We got x equals 2.312, but these two numbers don't match. Why not? Yes, because what did we just solve? A. We solved A. We didn't solve x. E to the x is A. Now we have to solve for x. That's why it doesn't work. It's not the correct answer. So e to the x is equal to 10.099, or e to the x is equal to negative 0.099. How do I solve for x? Natural log. Natural log cancels out the e because they have the same base. So the first answer is natural log 10.099. The second answer is natural log negative 0.099. Or is it? Natural log negative 0.099 does not work. Why not? Yes, we can't have negative in the log. So that answer, you don't even have to check. It's not going to work. Okay, so now go ahead and check this answer and see if it's actually the same as the one you got from the graph, because it should. 2.312 should be the answer. And see if you get that. You guys got 2.312? Yes, okay. 2.312. All right, so that's the answer. So, on the actual test, you will have a calculator with you, so you can always double check to see if you have the correct answer. All right, let's have you guys try one on your own. Number 1. And, if you need your partner, please talk to each other and help each other out. That way you guys can all get it and move on. So number 1, check that one or solve that one. Number 2 is harder, so you gotta think a little more on number 2. Okay, number 1, the answer is x equals natural log 1/2 or negative 0.693. Okay, number 2, you need to kind of start the same way. So 2 to the x plus 2 to the negative x equals 6, and then go from there. This is not as easy as the previous 2 problems because the base is no longer e. So you can't use a natural log to cancel that base. You do need to use a log base 2 if you want to cancel. If you cannot cancel, then you need to either change base or use other logs, but you gotta solve for x by getting rid of that base 2 eventually. So solve first. Let me know if you're stuck or if you're done. At the very end, the answer is 2.543 or negative 2.543.